Hello, we're Group 1 and we're going to present you a lab guide to show how to deploy Docker images in cloud. Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. Containers allow a developer to package up an application with all the parts it needs, such as libraries and other dependencies, and ship it all out as one package. By doing so, thanks to the container, the developer can rest assured that the application will run on any other Linux machine, regardless of any customized settings that machine might have that could differ from the machine used for writing and testing the code. Containers are usually helpful for improving security, reproducibility, and scalability in software development and data science. The chosen public cloud for this lab is Google Cloud Platform, GCP, which is where the Docker images will be deployed. Google Cloud Platform, offered by Google, is a suite of cloud computing services that runs on the same infrastructure that Google uses internally for its end-user products, such as Google Search and YouTube. Google Cloud Platform provides infrastructure as service, platform as service, and serverless computing environments. Now, we're going to introduce you to the main tools used for this project. Let's start with Terraform. Terraform is an open-source infrastructure as code software tool created by HashiCorp. It is an orchestration tool for building, changing, and versioning infrastructure safely and efficiently. It also supports a number of cloud infrastructure providers, including the one we are using and have previously discussed, Google Cloud Platform. It enables users to define and provision a data center infrastructure using a high-level configuration language, known as HashiCorp Configuration Language. It allows a blueprint of data center to be versioned and treated as would any other code, and also the defined infrastructure can be shared and reused. One of the great features of Terraform is that it supports multiple providers, meaning that it's possible to create a multi-cloud infrastructure and manage it efficiently. We will use Terraform to orchestrate our instances in Google Cloud Platform. Another tool that we're going to use is Ansible, which is a simple IT automation engine that automates cloud provisioning, configuration management, application deployment, intra-service orchestration, and many other IT needs. It is also considered a configuration management tool for the automatic deployment of IT infrastructures, meaning networks and compute instances. But in this lab, it will be used to configure the compute instances previously deployed by Terraform with applications and services in a process that can be called full stack automation. We will use Ansible to automate the configuration of our instances in Google Cloud Platform. We're also using Docker Swarm to orchestrate our containers. A swarm is a cluster of one or more computers running Docker. Docker Swarm works as a container orchestrator, which is used for deploying Docker containers to production. Docker Swarm manages a cluster of nodes where the containers can be deployed. As we can see in the image, there is a swarm with one manager and 3 workers. Lastly, Google Cloud SDK will be used. Google Cloud SDK is a set of tools that you can use to manage resources and applications hosted on Google Cloud Platform. These include gCloud, gSerl, and BigQ command line tools. As a service, we chose a project that simulates a shop, where one could create an account, log in, and place orders, which is constituted by the following building blocks: a Java REST application written in Spring Boot, a database for product inventory, customer data, and orders, a React shopping cart, an Nginx reversed proxy implementation HTTPS, and finally, a payments gateway to simulate certificate management. So far, so good. But now, let's see how it works.
So now that we have finished our presentation, we are going to do a demo. To do so, first we are going to create a new project in Google Cloud Platform. Coming here, new project. So now we have to name it, and we're going to name it AGISIT 2019 test, and press create. While it is creating, we can come to our workspace. In my case, So users, AGISIT, right here, and check the Vagrant global status to verify that there is no machines running, and if they exist, it is good to halt them and destroy them because of conflict names, right? So there is no machine running. Coming here, we can see that our project has been created. Next, we have to generate the Google Cloud credentials that we are going to use in our Ansible, in our management notes. For this, we came here, API service, dashboard, enable APIs and services, search for compute engine API, and press enable. It will take some time to enable this service. So while it is enabling, we can come to the folder where we have the zip. First, we come to the AGISIT folder, to our workspace, and we are going to create a folder here named Swarm Cloud, right? And then we came here and extract the files to that folder, Swarm Cloud. Select folder and extract, right? I'm going to open this on codes to have it here open. Okay, and it's still enabling. So I can, while it is enabling, I can explain you how it's gonna boot the machine. It's gonna boot using this file, the Vagrant file, with these rules, right? With this IP. It's gonna share this folder, the GCP tenant, and will provision this file, the bootstrap, that will install the necessary software on the machine, right? So we can proceed to the boot up, right? So we enter the folder and one more. Yeah, and run the command vagrant. And it starts booting up the machine. In this case, create the machine and booting up. So the process is enabled. So to generate the credentials, we come here, press create credentials. So in the service name, we can put new service thread, generate a random ID, and press create. It is optional, but we can select a role. In this case, we are going to select the owner role to have full access to all resources, and press continue. Press create key, and here the key type will be JSON, right? And press create. The JSON file will download. It's here on the downloads, right? And we are going to name it to the following: AGISIT 1920 Google Cloud, and place it in the Terraform folder. right? First, it is booting. So we're gonna wait some minutes, some time while it is booting, and when the machine is up, we're gonna return. Machine has booted, as you can see. First, we are gonna move the credentials to here, to Terraform folder, right there, and we're gonna vagrant SSH to the management node. So the next step is to authorize the Google Cloud SDK in order to allow controlling the GCP resources from here. For do this, we're gonna move to GCP tenants, Terraform, write gcloud auth login. It will generate a link to perform the authentication. We come here, paste the link, log with the account associated to the Google Cloud Platform, copy this code, paste it here, and now we have login and we are able to manage the resources. Okay. Next, for generating the security key pair for SSH trusts, we come to this folder, run the following command, SSH keygen with these parameters, RSA, F. You're going to look at the file in this folder, SSH GCP engine RSA. We have the 2048 length and with Ubuntu. Press enter and the key pair was generated successfully, right? So now we are going to start with the deployment of the infrastructure using Terraform. For this, we come to the Terraform folder, right? But first, we have to update the variables that Terraform uses to manage the resources, right? For this, we have to come here to Terraform variables, and first we have to place the name of the JSON of the credentials here, the file of the credentials, and the name is AGISIT 1920 Google Cloud.json, and here the project ID. The project ID, if you come here, is easy to see, is that one. And here, paste it, and the variables are set. So now, these two files, the swarm workers and swarm manager, create the instances themselves, right? With this name, this machine type, this zone, all these vars are set here in the variables.tf. The provider sets the provider, which is Google. User credentials, the var project, the var zone. The outputs is what Google uses to send these values. In this case, are the IPs of the manager and the workers. The network file is the rules of the firewall, right, of the network. And lastly, we have the inventory. This file was created to automate the process. And how is it automate the process? it uses two template files, right? The inventory and updated hosts, and it automatically populates the Ansible inventory, which is the inventory that will be used by Ansible to know the hosts, right? And populate the etc. hosts, right? By doing this in this way, if you want to scale up the number of instances to hundreds and thousands, you would have no extra work doing that, because all the process is automated and you don't have to fill the IPs by hand manually, right? So to deploy this infrastructure, we're gonna Terraform it. Terraform plan, the changes that will be made, right? Terraform apply to apply the changes. Yes. And this will create all the infrastructure needed. Again, it will take some time, so we're going to return when it finishes. So, as you can see, the apply command was done successfully. 9 resources were added. The swarm manager has this IP, and the workers have these IPs, right? So now we're gonna use Ansible. No, before using Ansible, we're gonna establish the SSH trust, right? SSN, and to do that, we have to run SSH key scan to gather the keys, the public keys from the instances, and save them here in our management node. To do that, we have to run the SSH key scan, as you can see here in the script that we have created, with all the names here of the instances, right? Manager, worker 1, worker 2, worker 3, etc. Once more, to automate this process, we have created a script. This time we created a script to do this automatically. This script can be integrated as part of the Terraform, right? But we decide to do that in a separate way, because we want to maintain the conceptual differences separated. Okay, so now we have to run this script. And once more, if you want to scale this process to hundreds, thousands of nodes, the process will require no extra work, right? So we're gonna move to Ansible folder, right? First, we have to load the credentials generated by Google Cloud to Ansible. To do that, we're gonna source Ansible load credentials, right? It's okay. CD to Ansible folder. In here, we can. It's always good. It's always a good practice to test the connectivity of the instance. So we're gonna SSH to one of them. In this case, you have to use this file. Oh, this file is not created. SSH, it's there. GCP RSA, Ubuntu. For example, to worker 1. And we are on the instance, right? Exit, and finally, Ansible playbook with the inventory that contains the hosts, the main. So it starts configuring the machines. As you can see, if you come here to the Ansible folder, we have a main file with displays that is install Python, both in workers and manager, in its swarm cluster, in manager, join, executed by the workers, and deploy the Docker image in the manager that will then distribute the image to the cluster. These names of these roles have to match the roles presented in this folder, right? And each of these roles have a separated file, have a dedicated file. As you can see here, for example, there is a file of swarm join, right? These are the tasks that are executed for each worker. So it will once again take some time to run these tasks. So we're going to return when it has finished. Now, as you can see, the process went very smoothly. It means that our infrastructure, our project infrastructure, has been configured, right? And the Swarm cluster are running with the desired service. To confirm that, we can SSH to the manager machine, right? By running these commands. We're going to use these credentials, and we're going to enter the manager nodes. Right. First, let's see the nodes that are running. Right. Node alias. All nodes are ready and active. Nextly, let's see the services. So the services are deployed. So we can come to a browser, right? Let's see first an IP of a worker, for example. It can be a worker or a manager because the Swarm cluster will redirect the request to the machine that is better to response, right? Let's see this worker. To port 1880. Wait, let's check what is happening. Let me check. The process, the machine was rebooted by the Google Cloud automatically. So let me just go to there to check. It's running. Just to see Docker is running. Okay, now it's all running. As you can see, the machines were rebooted, right? This happens because Google Cloud from time to time in these free accounts reboot the machines, and now as you can see, the page was refreshed and now the machine is up and running our service, right? Which is a shop that you can add and buy things. And as you can see here is the IP of the machine of the worker that serves your request. And if you hit enter, yeah, as you can see, the IP that served our requests has changed. So everything went smoothly, and the swarm cluster are deployed with the desired service. So now, to clean up our our environment, first we have to destroy the instances. For this, we run terraform destroy, right? Terraform destroy, and then after it, we're gonna run vagrant out and destroy. It will take some time to do that. Once again, we come back when it is finished. All the resources were destroyed, and now if we come to here, there is no VM instance running. So we exit the management nodes and vagrant out machine, and after that, vagrant destroy the machine and the environment. So it will be fast, so we're gonna run it. As you can see, by running vagrant global status, that there is no machine here, so the demo has finished, right? So thank you for your attention, and this was our project.